C part, that is the limit x tends to 0 sec x minus 1 upon x square. If we put x is equal to 0 in the numerator at the place of x, okay, let me first tell you. Here we are using the trigonometric functions. Trigonometric function. So what we can do here, just put x is equal to 0. So sec 0 is 1 and 1 minus 1 is equal to 0. So numerator we have 0 and let's see denominator x is equal to 0. If we put x is equal to 0, so 0 square is 0. So again we have 0 by 0 form here. And this is what we can call it as, this is indeterminate form. This is indeterminate form. So just try what we can see here. If we multiply the conjugate of this function, so that would be sec square x minus 1, and we know that the identity sec square x minus 1 is equal to tan square. So okay, let me tell you, like limit x tends to 0 sec x minus 1 upon x square. If we multiply the conjugate of the numerator, then sec x plus 1 upon sec x plus 1. So we know that is a square minus b square is equal to, in the first round bracket we have a minus b, and in second round bracket we have a plus b. I'm just using this concept to solve the numerators. Okay, let's see. Then what we have, the limit x tends to 0. Here what we have sec square x minus 1 upon x square sec x plus 1. So if and one thing what we know here, trigonometric identities, like 1 plus tan square x is equal to sec square x. So tan square x is equal to sec square x minus 1. So we directly we can put tan square x at the place of sec square x minus 1. So here what we can do, the limit x tends to 0, and we can put at the place of sec square x minus 1 is equal to tan square x. So x square x we have in denominator like sec x plus 1. So if we again put x is equal to 0, now we can find out the limits value. So tan 0 is 0 and x again 0 by 0 form. Let me repeatedly solve this limit. Okay, so limit x tends to 0, and how we gonna solve this? Just remember the concept of tan square x is equal to sin square x divided by cos square x. So we can just put the sin square x upon cos square x at the place of tan square x. So we have sin square x upon cos square x, and here what we have 1 upon x square, and inside the round bracket we have sec x plus 1. So what we gonna remember here, just remember the concept of like sin square x upon x square x. We can write it as sin x upon x, which is going to be whole square. We can write it as this term, which is let me tell you, this term we can write it as like this. So here what we can see after that, so limit x tends to 0 sin x divided by x, that is going to be whole square, and 1 upon cos square x, and then we have again 1 upon sec x plus 1. So we know that the graph of the sin x upon x, just see the graph of the sin x upon x. Yes, here is 0, here is 1. This is the graph of sin x upon x. So for these values, for the sin x upon x, what we can say, the value is going to be 1. If we put x is equal to 0, this function is going to be 0, then the value would be 1. So what we have here is 1. Yes, and let me solve with the 1 upon cos square x. So what we can put here, we can put x is equal to 0, cos 0 is 1. Yes, and here what we have, if we put x is equal sec x is here, and we can put x is equal to 0. So sec 0 is going to be 1, 1 plus 1, this is going to be 2. So the value is equal to 1 by 2. This is going to be answer.